Custom comparison for built-in containers. In my code there's numerous comparisons for equality of various containers, list, dict, etc. The keys and values of the containers are of types float, bool, int, and str. The built-in equals and not equal worked perfectly fine. I just learned that the floats used in the values of the containers must be compared using a custom comparison function. I've written that function already, let's call it a proxequal, and assume that it takes two floats and return true if they are judged to be equal and false otherwise. I prefer that the changes to the existing code are kept to a minimum. New classes /functions /etc. can be as complicated as necessary. Example. The dict1 not equal dict2 condition needs to be rewritten so that any floats used in values of dict1 and dict2 are compared using a proxequal function instead of _eq_. The actual contents of dictionaries comes from various sources, parsing files, calculations, etc. Note, I asked a question earlier about how to override built-in floats eq. That would have been an easy solution, but I learned that Python doesn't allow overriding built-in types _eq_ operator. Hence this new question.
The only route to altering the way built-in containers check equality is to make them contain as values, instead of the originals, wrapped values, wrapped in a class that overrides _eq_ and _ne_. This is if you need to alter the way the containers themselves use equality checking, for example for the purpose of the AND operator where the right-hand side operand is a list, as well as in containers methods such as their own _eq_. Typex._eq_y is the typical way Python will perform internally what you code as x == y. If what you're talking about is performing your own equality checks, without altering the checks performed internally by the containers themselves, then the only way is to change every cont1 == cont2 into, for example, same cont1, cont2, value _same, where value _same is a function accepting two values and returning true or false like == would. That's probably too invasive WRT the criterion you specify. If you can change the container themselves, i.e., the number of places where container objects are created is much smaller than the number of places where two containers are checked for equality, then using the container subclass which overrides _eq_ is best. For example, with same being as I mentioned in the second paragraph, and so forth for other container types you need, then wherever you have, for example, change it into. And be sure to also catch other ways to create list objects, for example replace with and with and so forth. Yeah, I know, what a bother, but it's a core principle, in practice, of Python that built-in types, be they containers, or value types like for example float, themselves cannot be changed. That's a very different philosophy from for example Ruby's and JavaScript's, and I personally prefer it, but I do see how it can seem limiting at times. Edit, the op-specific request seems to be, in terms of this answer, how do I implement same for the various container types, not how to apply it without changing the == into a function call. If that's correct, then, e.g., without using iterators for simplicity. Note that this applies to values, as requested, not to keys. Fuzzying up the equality comparison of a DIC's keys, or a set's members, is a real problem. Look at it this way. First, how do you guarantee with absolute certainty that summary value A, B, and summary value B, C, totally implies and ensures summary value A, C? This transitivity condition does not apply to most semi-sensible fuzzy comparisons I've ever seen, and yet it's completely indispensable for the hash table-based containers, such as DICs and sets. If you pass that hurdle, then the nightmare of making the hash value somehow magically consistent arises. And what if two actually different keys in one DIC map to equality in this sense with the same key in the other DIC? Which of the two corresponding values should be used then? This way madness lies, if you ask me. So I hope that when you say values you do mean, exactly, values, and not keys.
If you wanted to see more, please consider subscribing.